You said there were antecedents to your discovery, and you mentioned this in your paper published in 1995. But you said that the field wasn't considered a serious topic. Was it because of resolution limits and false positives?
There's a long story in exoplanet science, if I can say that, before we found the first one. A false alarm, or people claiming they found a planet and it was not a planet. So maybe some people may have thought, okay, it's again the same kind of stuff, it's not a planet. And you have to realize we set up the instrument, and 1 year after the first light, I mean, practically we had the first planets, which is extremely quick. Usually you have to establish some confidence into the machine. We were very confident, but nobody was aware of these machines. Well, when the data were confirmed by Jeff Marcy, a couple of weeks later, people understood that, okay, the data are fine, they're being confirmed. But then came up the big debate, is it, okay, could you explain the data that we had? Because we just had a change in radial velocity by something else. We did carefully study that in the paper, but it was so controversial. And some people suspected that maybe there are some effects, subtle effect on the atmosphere of the stars, like an impossible pulsation, which is not observed on other stars, but could apply on that one. That was ruled out in our paper, but I don't think they understood it the way we did it. And then for some time, people were arguing whether it was right or not. And then, despite the fact that a couple of years later, some people realized that this was wrong, this paper, claiming that the effect was not true, is still there. And the community was still not very sure. Well, the people really working on the topic, there were maybe 50 people in the world, they were pretty sure that the planet was real. But the community outside the field didn't really know what to think about that. And they all know that the planet is awkward. So when you have a planetary theory and data doesn't match a theory, usually the global physics attitude is being skeptical. Somebody tell you, oh, I made an experiment and I found that this particle go faster than the speed of light. While you say, come on, this is a big theory. So if you do that, there's the consequences. It was not that bad because I think formation theory is not like fundamental physics theory. But we had a nice picture of the solar system. And then people were not really, willing to trash it. They say, no, it works for the solar system, so maybe there's something wrong. So it takes some time to swallow. And usually what I learned later on is the bigger is the discovery, the longer it takes for the discovery to be understood. So if you're doing incremental science, usually it's fine, everybody is expecting it, you're happy, you go to your paper, everybody will be citing you. In our case, it was so awkward. And we are also the people trying to build up a theory that there were some attempt early on, but it was very debated, and a new planet kept coming, and they were also awkward. So we had all these planets popping up that was not exactly the way everybody was expecting it, and it takes some time to get this right. And for me, it was certainly something difficult because I was just a PhD student. So in a way, I wanted to move forward to something else. I was a bit tired by that. It's people challenging what I did, and some people telling me, well, this is the greatest discovery ever. And I say, oh my God, I started my career by making my best ever discovery. So what I'm going to do next, it's kind of. So to me, I had to live with that, and I decided to put that aside. I said, let's move forward, and fine. I did what I could, and we did the best we could. And that's it. Well, it took me a long time to really understand the profound implication of this. And I think it took also to the community some time to realize that they were really a new field that I was setting up. The public reaction was amazing, and the public was enthusiastic, way more than my colleagues, physicist colleagues, and they were kind of a little bit reluctant. And then they also saw us like a little bit of a threat, because they say, oh, these people, they're asking a lot of resources, they want to do a lot of science, but my science is more serious than this kind of exoplanet stuff. Even some people told us, well, it's just fashion, it's not gonna last, guys. It's just trendy, and we had all this. So it's interesting to see how things can mature, and I know it's a very serious business because we're flying spacecraft on this. So it took about 10 years, I think, for the field to establish itself and to be understood and recognized as a very serious field of physics. And I hope right now I will be successful to move the field being serious enough, but to go beyond this and to go to the question of life in the universe. It's a very serious field. It's not only for physics, but also for chemistry, earth sciences. So there's this growing of a new field, and we made a new field of research here. And that's why we struggle. And that's why it was difficult to convince people. That's fair.
And you mentioned that in the summer of 1994, your PhD advisor gave you the keys of the observatory in South France. Can you tell us a bit about the story behind that, and how did you know what stars you needed to look for?
This is interesting because it tells you a lot what we were expecting. So nobody was expecting a planet like this one. The idea was to build the equipment. So equipment was clearly designed to get the right accuracy to find planet, and it was clearly the decision from the beginning to start the program. But surely enough, Michel told me, well, okay, start the program, I go in sabbatical, nothing will happen, but start the program. Are you aware that you start a long-term program and you will not be able to continue it? I said, fine. I did the equipment, I work on the equipment. I was very happy to demonstrate that the equipment was working properly. So I started the program, and then we have 100 stars. We selected the star on purpose to be different from our competitor in Berkeley, Jeff Marcy and Paul Butler. We know they were doing the same, and we know it would be a long race, a long run. So I really went there to say, okay, let's start and wrap up my PhD, and then I will do something else. I took 20 stars out of this 100, which was very easy to take because they were the brightest one. And I decided that these stars would deserve a bit more measurements than the others, just to check the machine. So I took 2 data points every week, and I had 1 run of observations every 2 months. So I started, get 2 points. 51 Peg was one of them. It was not the only one being observed. There were 20. So I started. And then after my 2 first runs, I came back in January 95, and I kept observing that star. And there was something awkward with the data. They were not stable. And I started to panic here. I say, well, there's something wrong maybe in the data processing about that stars. So I really get a bit obsessed by that object, kept measuring it, trying to understand, try to debug the system, up to the point I realized that everything is fine. My system is working properly. There is no mistakes because it works for the other star, only that one. So there must be something special on that stars. I look at that stars. I didn't find something special. It looks like an old stars, like the sun. I said, so there must be something orbiting that star. And I tried to fit an orbit. I wanted to come up with the real explanations to Michel. He was in Hawaii anyway. The communication was very loose because in these days the email was kind of starting. So I said, I'm gonna go to the end of this, I'm gonna find this, I'm gonna get the orbit. And then at the end, I found an orbit, and I said, okay, I think I found a planet. And at that time, it's fascinating because I don't think I realized what it meant, really. Because to me it was cool, I found a planet, cool, yeah, 4 days planet. But I didn't realize it was impossible. And when I mentioned this to Michel, he said, oh yeah, maybe, and let's see what I think he didn't believe me. It was obvious. And then he explained to me carefully, you know, Didier, a planet like that could not exist. Because the formation theory says, and then he explained to me all the story, and I said, oh, I didn't know that. I had these very naive perceptions, why not? The fact that I didn't know it was a kind of good news, because I get focused, obsessed, I get the orbit. And at the end, I explained what I did to Michel, and he had to admit that he has no other explanation as well. But it was so awkward that he told me, look, Didier, we're not going to do anything with that. It's so special. We have to leave it as it is, and we have to come back with the telescopes. And we're going to do a little bit of a game here. We're going to use the textbook of the physics. The textbook of physics tell you, when you have a theory, whatever theory it is, the only thing which matters is not how nice is the theory, how evolutionary is the theory, how beautiful is the theory. What matters is, does the theory reflect the data? You can always find a theory matching data. It's an easy game. You can twist a theory. But it's much more difficult to make a prediction with a theory that is matching, that will be matched by the data. This famous experiment about the prediction of Einstein, where they went to see the solar eclipse, all this. So we say we have to do the same. So if this is a planet, your orbit should be valid. So when we come back to the telescope later on in July, when the star will be back, your prediction should be matched. And I say, okay, let's do that. So we forgot that, and we realized that because it was a bit of edgy, we didn't want to talk too much about that. We just waited to be back on the telescope in July. And in July, we went to the telescope, and it was like a dream, because it was exactly the textbook stuff. You have the theory predicting something, and bang, 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 all the data points were exactly matching the prediction I made in February. So at that time, I think Michel was get convinced. He said, oh my God, that is real. So let's write the paper, because it's so easy. It's 4 days. Anybody could do it. Maybe Jeff Marsing's doing it as well. So we decided to not talk to anybody, except the very close family, rush to the paper and submit the paper. And that's the paper you have here. The referee said, well, I don't believe you. It's an alias. And they say, okay, what can we do? Well, get more data. So we went back to the telescope in September. That's why we have September. And then every day we were bang, bang, bang. I think we have 2 or 3 data points every night this time to demonstrate it was not an alias. And then we added the data point to the paper and we submit right away. And then we have to wait this impossible 2 months where I think nature didn't know what to do with our paper. Because the older referee said it's fine. There were 2 theoreticians that they said, well, the only way, the theory we mentioned migration, we mentioned way, and we didn't know exactly how to make the theory, but we just put that on the paper. So, well, there must be something like that. And they say, yeah, maybe it's going to work. There is where to do that. And the one dealing with the data, he said, it's fine. I checked the data. This is the only possible orbit. They should be published. And nature delayed and delayed and delayed and delayed and delayed. And up to the point we say, we're going to announce into the world. We cannot wait for much. I need to say, well, but you can do that. But don't say that we accepted the paper. When we made the announcement in Florence, the world was very skeptical. And we were lucky in a sense that our competitor in Berkeley, Jeff Marcy and Paul Butler, they were observing at the telescope. And somebody told them, look, there is a star that the Swiss guy pretend it's a planet around. It's just 4 days period. And could you have a look at it? They say, of course, I'm going to check it. And Marcy was well known to be a planet killer in a way that in the past he already killed a lot of claimed of planet. And to me that was fascinating because the only thing I feel a little bit on the thread is the data will not be confirmed. And what happened is in 1 week after, Jeff Marsing sent us this very nice email saying, well, look guys, I confirm everything you said. This is real. Congratulations. You found the first planet. And to me, that was such a relief because I say, okay, he confirms the data, so everything is fine. And then we got a bit lucky here because that helped to strengthen I think the facts in discovery. But it turned out not to be enough for the community at large. But it was enough for the people that were really interesting to look for planet. Nature at that point decided, okay, maybe we should accept the paper because it's too late to stop it. But we have been very close to be rejected, I think, by the editor, I'm sure, because it was too big and we were nobody. And some people told us after, I heard sentence like, well, how come NASA is using billions and to spend spacecraft and we didn't detect the first planet? This is 2 Swiss guys somewhere using a kind of a telescope that built in 1957 in an observatory that was about to close. So I think the story is very fascinating in terms of sociology. I just learned recently that we're part of the best 10 papers into Nature, so now they have changed their mind. We went to be barely accepted to the 10 best.